I will show you a demonstration of TeachableMachine. TeachableMachine is a website provided by Google with the URL teachablemachine.withgoogle.com, and this online software will help you to train a neural network model to recognize images. So let's start. So you first press Get Started, and here you have the choice between three types of project: image project, audio project, where you will learn, where you will teach the model to learn to recognize different sounds like hello or goodbye. And the third kind of project is a pose project, where it will skeletize an image of human to recognize the position of the leg, the position of the body, and the position of the arm on the head. So we will just focus on the image project. So here you choose between standard images and the embedded image model. So let's say we will try this one. So this one will capture images and resize these images to the 224 by 224 color images, which are compatible with the model, the deep learning model used by TeachableMachine. Okay, so first let's record some images for the training of the model. So we will just recognize between hand images and fist images. So for hand images, I just press on the webcam here. So I have a webcam. I will put my hand like this, and I will press the Hold to Record button. And during the time I press the Hold to Record button, the system will record images. So let's do it, and I move my hand. So I have different types of images with my hand in different positions. I will do the same for fist. Okay, so now, and I will add another class. I will say nothing. I will call it nothing, and with nothing, I don't put my hand. Okay, so now I have three data sets of images, one with hand image, with image of hand, another one with image of fist, and the third one, the image with nothing. So we press the train button. So all these images will be used to train the model. It's relatively fast. Okay, and now we have the output, and here you have the recognition. So it recognizes that there's nothing on the image. If I put my hand like this in different position, it seems to be quite good. If I move here back, if I really move it very far away, the system is puzzled because I didn't teach it my hand in this position. My hand was very close to the camera. So here, the probability of recognizing is about 100%. And for the fist, it's the same. I can move it, and the probability is about the same. If I have something like this, for example, which correspond to an image that didn't belong to one of these categories, you see that the system is quite puzzled. Okay, so You test your model, and here it seems to be good. Okay, and when you think your model is okay, you can export this model. And for example, you can download your model. When you download it, TeachableMachine will generate a zip file which contains two files. One which is named label.txt, which contains the number 0 on the number 1 on fist, the number 2 with the string nothing. It is helpful to have a correspondence with the index 0, 1, 2, which will be the output of the recognition of the model provided by the model. And if you want to have more informative information, instead of 0, 1, or 2, with label.txt, you have and, you can get the word and, fist, or nothing. But the most important file is keras.h5, which is in the zip file and which corresponds to the model with the weight of all the connection between the different neurons. So here you have an example of a Python program which load an image, first load the model after unzipping, which loads the label.txt file. And here you put a path to an image. So the image is loaded as a RGB image. It is resized to the size compatible with the model. We do some transform to this to normalize the image. Instead of having each pixel ranging from 0 to 255, we compute we shift the range to -1 to +1. So after normalizing the image, we can send this image to the model, to the predict function of the model, and we get a prediction. The prediction is the value of probability for each of the three classes. For example, here we can see the probability for the first one is something like 0. The probability for the second one is about 80%. The probability for the second one is about 20%. So you will get this in prediction. So if you use this function, argmax, you will get the index of the probability which has the highest value. So here, for example, if I put a fist here, you will get the number 0, 1. You will get the number 1, which is the probability of the highest class. So with this index, you can get the class name, so the name fist here, and you can print this. So it's a very basic example which process only one image. Here you have about the same program instead, but the difference is instead of using images, it uses a camera, the output of a camera. So here we use OpenCV, which is a big computer vision library. With OpenCV, we connect to the camera in position 0. And in a while loop, you will get each image from the camera, do the same processing than before, and print the class and the confidence score for this prediction, and loop to the next image provided by the camera. So with a teachable machine, it's quite easy to train a model, use this model from a Python program, and instead of just printing the result, you can use this result to do something, to do an action. For example, if you put this model on a Raspberry Pi, with the input-output of your Raspberry Pi, you can interact with your environment to do some action corresponding to the object which is detected by your webcam.